Hi, this is Mr. Snyder, and today's lesson is over prime factorization. So today's objective will be to learn about both prime and composite numbers, as well as to find the prime factorizations of those composite numbers. So here we go. The vocabulary that we'll need to know today is prime number, which you should already know, composite number, and also prime factorization. In 1999, a gentleman from India, whose name I will not try to pronounce, discovered the largest prime number so far known to man, and if you look at that number, that is a 2 with a gigantic exponent. The exponent is 6,972,593. So once you get that number and subtract 1, you have his prime number, and by the way, that number is over 2 million digits, which is incredible to think about. A 2 million digit number that's only divisible by 1 in itself. So, anyway, a definition of a prime number is a whole number greater than 1 that has exactly 2 factors, as I mentioned, 1 and itself. So 3 is an example of the prime number because its only factors are 1 and 3. 5 would also be another example, 7, 11, 13, 17, 19, so on. All those numbers are examples of prime numbers because they're divisible only by 1 and themselves. A composite number, on the other hand, is a whole number that has 2 or more factors. So 6 would be a fairly easy example of a composite number because it's got factors of 1 and 6, because 1 times 6 is 6, as well as 2 times 3, because 2 times 3 is also 6. So all 4 of those numbers are factors, which makes it a composite number. The number 1 has exactly 1 factor and is neither prime nor composite. And another interesting fact is that 2 is the only even prime number. So part of your homework today will be to tell whether each number is prime or composite. So I've already mentioned that 11 is a prime number because its only factors are 1 and 11. 16, however, has many factors, 1 times 16, 2 times 8, as well as 4 times 4, so it has all 5 of these as factors, which makes it a composite number. Let's look at 14. 14 is, of course, divisible by 1 and 14, as well as 2 and 7, and since there's 2 or more factors, that makes it a composite number. 7, however, is divisible only by 7 or 1, which makes it a prime number, because the only factors are 7 and 1, 2 factors. So let's talk about prime factorization. Prime factorization is when you turn a composite number into the product of all its prime factors. So you can use a factor tree to find prime factors of a composite number, and we'll also look at another technique. Whenever I do prime factorization, I think of Legos. Everybody's played with Legos and built a wonderful structure. But when you break that structure down into all of its parts, that's kind of what prime factorization is. It's breaking it down into the product of all of its factors, which happen to be all prime numbers if you have it broken down all the way. And you can write prime factorization using exponents. The exponent tells how many times to use the base as a factor. So let's look at what this is going to look like. When you want to write something in prime factorization, the first method is using the factor tree. So just think of 2 numbers that you can multiply to get the number given. In this case, the number given is 24. So 2 numbers that would multiply to be 24 would be numbers like 8 and 3. I could have chose 6 and 4. I could have chose 2 and 12. It doesn't matter. I'll get to the same prime factorization. So let's start with 8 and 3. If the number is composite, you continue to break it down. If it's prime, you can either circle it and leave it alone there, or just continue to bring it down to the final row. I prefer to just circle it and leave it. The PowerPoint, however, will show that you will bring it down to the bottom, which is also fine. It's just a matter of preference. So let's look at 8. 8 is a composite number, so we can break it down again into 4 and 2. The 3 is a prime number, so it got brought down to the next row. Looking at the third row, 4 is a composite number, so it can break down again into 2 and 2. The 2 that's in the third row just comes down to the fourth row, and the 3 that's in the third row also comes down to the last row. So if you notice, the last row is all prime numbers. So that's going to be my prime factorization. but I don't want to write it 2 times 2 times 2 times 3. I want to write it a little bit more efficiently, so I'm going to write 2 to the third power times 3, and that will be the prime factorization. Let's look at 36. Again, you can start with 6 times 6, you can start with 18 times 2, you can start with 9 times 4. It doesn't matter, you will get the same prime factorization. So let's do 18 times 2. 18 is a composite number, so I can continue to break that down. 2, however, is prime, so I could circle it and leave it, or as the PowerPoint does, I can bring it down to the next row. And just continue bringing it down until you're to the last row. So in the third row, I've broken 18. Since 18 is composite, I can break it down again to 9 times 2. You'll notice the 2 from the second row has slid down and is just kind of following along. On the third row, 9 is composite, so I break it into 3 times 3. I bring my other 2's along, so the very last row shows that I have all primes. 3 times 3 times 2 times 2, which can be written a little bit more efficiently as 2 to the second power times 3 to the second power. And it is customary to go ahead and write your smallest prime number first, so 2 to the second power gets written before 3 to the second power. There is a second method, a lesser known method, and it's really a matter of preference as to which method you prefer. The next method is called the step diagram, and at each step you're going to divide by the smallest possible prime number, and you're going to continue to do that until you get a 1 as the quotient. So this is kind of like upside down division. That's what it always looks like to me. So let's go ahead and see how this works. So again, think of the smallest prime, the smallest prime that you can divide by, I should say. So the smallest prime I always try first is 2, but since this is an odd number, that obviously won't work. You could try 3, but if you remember your divisibility rules, the sum of these numbers is not divisible by 3. The obvious choice is 5, because it ends in a 5, so let's go ahead and divide by 5. When you divide by 5, you would 5 goes into 275 55 times. So like I said, it's like upside down division. You're bringing your number down instead of up. The smallest prime I can think of that goes into 55 would be 5 again. So I divide by 5, I get 11. The only prime number that I know that goes into 11 is 11 itself. So that would be the smallest prime number that goes into it, and it goes into it exactly 1 times. And remember, once you get a quotient of 1, you are done. So the prime factorization is those red numbers on the left, which would be 5 times 5 times 11, or written more efficiently, 5 squared times 11. Let's look at 324. Not an obvious number to work with, but since it is even, I certainly know it's divisible by 2, and I'm just going to keep chipping away by dividing 2 as long as I can, and then we'll go from there. So let's divide by 2. If you divide by 2, you get 162. 162 is another even number, so I can divide by 2 again, and I get 81. 81 is a little bit more familiar of a number, and I know that it's not going to be divisible by 2 because it's not even, so I'm going to try 3. And it is divisible by 3. It goes in, 3 goes into 81 27 times. 3 also goes into 27 9 times, and 3 goes into 9 3 times. And I just continue working down using division until I get a quotient of 1. Once I get a quotient of 1 at the bottom, I just kind of piece together all the red numbers to the left, which would be 2 times 2 times 3 times 3 times 3 times 3. Better written as 2 squared times 3 to the 4th, because there's 2 2's and there are 4 3's being multiplied. So that's what I have written in the bottom left. So let's do a couple on your notes. So on your notes, you do have your definitions of prime composite and prime factorization. So let's try each method. So you'll remember the first method is the factor tree. So let's choose a number, let's say 48, and we'll work it out each way. So we'll do the number 48, and the best way I know to break up 48 is by doing 6 times 8 And then we look at 6. We ask ourselves, is 6 prime? And the answer is no, it's composite. So it does break down again into 3 times 2. 3 is prime, so I'm going to go ahead and circle it. 2 is also prime, so I'm going to go ahead and circle it, and then we'll work on the other branch. We'll work on 8. 8 obviously is a composite number, so we break it into 2 times 4. And 2 is prime, so I'll go ahead and circle that one, and then I'll continue with 4 because that is composite and it can break down even further. So you'll notice I'm doing it a little bit different than the PowerPoint. Whenever I get a prime branch of my factor tree, I go ahead and circle it and leave it. And once all my branches are circled, I know I have all primes, and then I can go ahead and write the prime factorization. Notice there are 4 2's, so I could write that as 2 to the 4th power, and there is 1 3, so I would put times 3, and it's obviously to the 1st power, so I don't need to give it an exponent. And that's my answer. Let's go ahead and try that same problem using the step method. So remember, the step method is upside down division, so we'll go ahead and write 48. And you want to divide by the smallest prime possible, and since it's an even number, I can divide by 2. And 2 goes into 4 twice, it goes into 8 4 times, and then I kind of move down the steps. I have another even number, so I can divide by 2 again. I get 12. 12 is even, so I can divide by 2 again. I get 6. 6 is even, so I can divide by 2 again. I get 3. 3 is not divisible by 2, so I divide by the smallest prime I possibly can, which is 3, and I get 1. Once I have the quotient of 1, I'm done. Just look to the left, and that's your prime factorization. 2 times 2 times 2 times 2, which can be written as 2 to the 4th times 3. And you obviously don't need to do anything with the 1, because adding 1 in your prime factorization doesn't change anything. So that's it. That's all I have for you. If you have any questions, please don't hesitate to ask.